Okay, so welcome everyone. Welcome in this session. So this is a session where I'm going to talk about OAuth. I'm Pieter Philippaerts. I'm a research manager at the Disciplinet Research Lab. So we do cybersecurity. I'm going to talk about OAuth, but not really like the OAuth protocol. So we're not going to do like a deep dive into the security specifications of the OAuth protocol. But what I am going to do today is I'm going to talk about a tool we have created that allows you to basically test your OAuth authorization server implementations, and automatically or semi-automatically, you will see, to test it for basically it's the compliance with the security specifications in the various OAuth standards. Okay. So in the first part of this talk, I'm going to introduce a tool, so you basically know what it looks like, how it works, what to expect. And then in the second part of this talk, I'm going to talk about an analysis we've done on 100 publicly available OAuth websites. So basically APIs that use OAuth to handle their authorization. And we basically tested them with this tool, and we're going to talk about the results we got, how good or how bad the results were. And I can already say that the results weren't that good. But that's for the second part of this talk. So as I said, so this is not a talk about the OAuth protocol itself. So this is not a deep dive. But for those of you who aren't really familiar with OAuth, I guess most of you know it. I mean, otherwise you probably would not be here in this session. But if you're not really that familiar, or if it's like kind of like somewhere back in your memory, let's do a short refresher. So basically, OAuth is an authorization protocol. It's the dominant authorization protocol for APIs. So that's why you're probably using it. And this is kind of like schematically how it works. So the idea is that you have like an application, third-party application, which is called the client here in the middle at the bottom. And this client wants to access some API on behalf of someone else, right? A user, right? So this is basically how it works. So the client wants to access a resource that is owned by a resource owner, which is typically a user. It doesn't have to be like a real person, but most of the time it is. So the client wants to access the user's data on the resource server via its API. And then there's this authorization server component that basically manages the authorization process and basically makes sure that this resource owner, this user, can give authorization to the client to access the user's data on the API. So if this still is a little bit abstract, let's use an example that makes it a little bit more easily understandable. So let's imagine we have like a video editor app. It could be an app on your phone, it could be a website, doesn't matter. And it's a video editor, so obviously it would like to have access to the YouTube API, right? To access, the YouTube users, their video files. So how does this work? So basically, if you're a user and you are using this editor application, you need to give it permission to access your YouTube videos, right? And that's what this Google authorization server is for. So what happens is this video editor application, when it needs access to your YouTube videos, it will send you back to your browser to Google's authorization server. There, Google will ask, like, are you sure that you want to give this video editor app the permission to, for example, download your videos or upload new videos or edit information or whatever? And when the user actually authorizes the application, so they click yes, I allow this video editor app to access my data. The authorization server redirects the user back to the video editor app, typically with something called an authorization code. And then the video editor app can use this authorization code to exchange it at the authorization server for something called an access token. And with this access token, it can access the YouTube API as if it basically were the user, okay? But only, of course, with the permissions that the user allows, okay? So this is a very short overview of how it works. So what we're going to talk about today is not how this protocol works, but we're going to talk about the security of OAuth. And so the first question, of course, is why do we need to talk about it, right? And the problem is that security vulnerabilities keep popping up. And this is actually surprising because the OAuth protocol has actually been around for over a decade. So it has been standardized in 2012, right? And a lot of research has been done on the protocol. And to be honest, it's rock solid. There's actually a formal proof in 2016 where researchers actually mathematically proved that there's no problem in the protocol. But still, we see things like this, where, for example, the booking.com website was hacked. So somehow it made a mistake in their implementation of OAuth, and people were able to hijack accounts, right? That's a big problem. Maybe a more well-known example is the GitHub problem from about a year ago. So somehow attackers were able to steal access tokens from multiple clients, right? And the attackers were able to access private repositories. That's not something you want. And truth be told, I mean, it's still unclear how the hack was done. So it's not necessarily GitHub's fault that the access tokens were leaked. But still, the question is, could GitHub have done something that would have somehow mitigated this attack, right? I think they could. So for example, they are using long-lived access tokens, which are basically access tokens that live for like time of the year. And that's a bad security practice. So if they would have used short-lived access tokens or standard constraint access tokens, the attack might not have succeeded, right? So, but how do they know that, right? How do they know whether they are compliant with the best practices or not? So somewhere last year there was also some buzz about these single-click account hijacking attacks. And so when reading about this, I actually read this in one of the articles where it said OAuth clients could reduce the chances of being victimized by reviewing OAuth 2.0's security practice guide, which could help against the account hijacking risks, right? And this is solid advice. If you are implementing OAuth, the only thing you need to do is implement it correctly, right? Because it is mathematically secure, right? There's a formal proof. So if you implement it correctly, and if you look at the security guidelines, you're basically set, and yeah, it's actually a good start. So how do you know if you have an OAuth implementation that you implemented it correctly, right? So when you typically choose OAuth, which is a perfect choice, what you typically do, I guess, is you buy some library or you use some open source library, right? So they implemented OAuth, you integrate it in your system, and you just assume that everything works correctly, right? That these guys that created this library, that they know what they're doing, that they actually read the specification, that they implemented it correctly. And if that is true, your system should be safe as well. The problem is that this might not be the case. And second, that even if it is the case, even if this library is implemented perfectly, well, then you still need to use it correctly, right? So you need to configure it. And if you don't know how to configure it correctly, you still might have vulnerabilities. If you're a little bit more adventurous, I would say, you could implement it yourself. Because if you actually look at how OAuth works, it's not that difficult, right? I mean, it's basically just an HTTP redirect and an HTTP post, and that's it. So it doesn't look very, very difficult. So you could implement it yourself, right? In that case, you obviously know what's in there because you've implemented it yourself, but then you still have to make sure that you have implemented all the necessary countermeasures as described in the OAuth specification. Okay. So the question is, if you have implemented OAuth, and when I'm saying OAuth here, I'm talking about the OAuth authorization server, right? So the component schematically that was on the top of the slide, previous slides. So if you have implemented this authorization server, how do you know that you've actually implemented it correctly? So if we look at other protocols, we see that actually there are tools that help you with this. So on the left-hand side, for example, you see the excellent SSL server test tool. You just go to azurelabs.com/SSL test. You enter the website and the host name that you want to test. Enter. It runs a bunch of test cases, and then at the end you get some kind of result that tells you like, well, okay, this is rating B because well, you're actually there's some problems with protocol support. So in this case, the deprecated versions of TLS are still supported, which is not the best practice anymore. And so you get this easy scoring system, and it tells you what's wrong and how to fix it, right? On the right-hand side, you see a similar tool. So this is for the HTTP security headers. So it will tell you whether you are using the various HTTP security headers correctly on your website. And again, there's an easy-to-use rating system. You can clearly see like, okay, A, it's probably good, right? You see that there are some features missing. It tells you what the problems are, what the potential vulnerabilities are, and how to fix it. Okay, so this is interesting. So for the SSL TLS protocol and for the HTTP headers. So inspired by these examples, what we did is we basically built a tool that does the same for OAuth. Okay, so this is what this first part of the session is going to be about. So what this basically is it's like a security test and compliance tool. So it runs a bunch of tests on your OAuth authorization server, and it checks whether this server complies with the security specifications in the OAuth standards, right? And gives you a nice report. So if you are interested in ISO 27001 certification, this could be really could come in handy. So you get a nice report that tells you that, well, yeah, the server is really secure because they really comply with the standards. Or obviously, if there are problems, it will tell you about it.
So act as identity server?
It acts as a client, actually.
Only the client part, yeah.
Yeah, so it tests the authorization server,
yeah,
but it acts as a client.
Okay.
Yeah, we'll come back to that. It's a good question. Okay. So in the first part of this presentation, let's talk about this tool. But before I dive into the tool and show you what it looks like, I will do that. But let's first talk about how it works, right? And so the tool starts from the OAuth specification. And so this is it, RFC 6749. So this is published in 2012, October 2012. So this is the first RFC that describes the OAuth 2 protocol. And so it's 75 pages long. You can read it. It's actually pretty easy to implement. So yeah, there's nothing stopping you from just downloading this and implementing OAuth yourself. So this is a security protocol. So this means that everywhere in the specification there are security constraints, security requirements, right? So there are things that you must do to make sure that your OAuth implementation is secure. And they're actually pretty easy to find in the specification because there's always like this keyword like must or may or should nearby, right? So the musts, yeah, these are the things that you must implement. So these are countermeasures that if you don't do it, that you probably have some kind of vulnerability or potential vulnerability. The shoulds are recommended countermeasures, but it might be that in your environment it's not practical, for example. So you don't have to do it, but if you can, you probably should do it. And the mays are just optional countermeasures. Like if you want 100% security, then you can implement these things as well. Okay. So the problem here is, as I mentioned, so it's a 75 pages document, but it's a framework. The OAuth 2 framework. So what does that mean? That means that it's like a pluggable thing and people can add stuff to it. So if you're implementing OAuth 2, it's probably not only this RFC that you will need to implement, but a lot of other stuff that has been standardized as well might need to be implemented as well. And so this is what you end up with. and it's kind of funny if you think about it, but it's really not. So this is RFC 6749. So this is the main OAuth specification, right? So this is one 75-page document. And these are all documents. Some of them are standardized. So these are the light blue documents. Some are upcoming standards. These are the red ones. Some are similar but related standards like TLS that you probably need, but that are somewhat different. But all of these things are related to any implementation that uses OAuth, right? So you probably don't need everything. I mean, so for example, so this UMAP2 grant is only for particular use cases. There are some RFCs that are probably not applicable to your situation, but it's a lot, right? And so this image is actually out of date. So a lot of the new upcoming standards are actually not even on there, right? So this is a 75-page document. So what, if we have to implement all this, how long will it take? So I actually did the page count only for the RFC, so the light blue standards here. And the final page count is around 770 pages, right? So you need to read 770 pages of specification. Each of these specifications has a number of security requirements, the musts, the shoulds, the mays. And you need to implement that to have like a full implementation of OAuth. And that's just a lot of work. There's a lot of things that can go wrong, and you probably shouldn't do it, right? So what did we do? So we actually took a look at these specifications. We selected the main specifications that people use. And what we basically did is we, for each of these specifications, we built a bunch of test cases, right? So tests that take like very particular things in the specification. They test it and they report like, is this in your implementation? Does it work correctly? Or doesn't it work correctly? Do you have the countermeasure or not, right? So for example, so in the main OAuth RFC, RFC 6749, there is this requirement that the client must not use the authorization code more than once, right? So I mentioned this briefly at the start of the presentation. So the authorization code can be exchanged for an access token. And obviously, if you have an authorization code and you can exchange it multiple times, if an attacker might somehow, get a hold of an authorization code, one that has been used before, they might just use it and generate a new access token with it, right? So that's not something we want. That's a potential vulnerability. So the advice that specification says the authorization code must be used once. It must be, you can only use it once. So how does OAuch test this? Well, it's actually very simple. We just get an authorization code from the authorization server. We try to exchange it multiple times, 2 times, and there's either 2 options. One, it fails. So this means that the server actually implements the countermeasure correctly, right? Or 2, the server just happily creates 2 sets of access tokens and doesn't care about the fact that the authorization code is used more than once. Okay, in that case, we know that the server didn't implement this countermeasure and that this is actually in violation with the specification. Okay, everyone's still with me? Okay. So in total, OAuch actually implements 113 of these test cases, right? And so they come from various RFCs and other draft documents. Also, of course, the security best practices documents, which is obviously an important document. And the thing is that sometimes the same security requirement, like one we just saw in the previous slide, occurs in multiple of these documents, sometimes even multiple times in a single document. And this sometimes leads to a situation where security requirement has different security requirement levels. So in one document, it might be a must. In another document, it might be a should or a may, right? And so this, for example, happened in the original RFC of OAuth and the security best practices. So in the original RFC, so that document says that a redirect URI must be explicitly should be explicitly matched to a pre-configured value. In the best practices, this is changed to a must, right? Because they've seen a lot of exploits that actually abuse that, and so they've just said like, okay, well, let's make it a must that these types of exploits cannot occur anymore. So in this case, OAuch on one hand sees like a should, and on the other hand sees like a must. So then it chooses the strictest value, which is in this case a must. Okay. So these 113 test cases are not all the security requirements in the RFCs. The RFCs, of course, specify the security requirements for the authorization server in which we are interested, but also for the clients. And we're not interested in the clients, so we just, these are out of scope for us. But even for the authorization server, some requirements are simply impossible to test. For example, there's a security requirement that says that that authorization codes, for example, should be stored encrypted in a database. Well, yeah, from remote, we can't test whether that's the case. I mean, you need to look at the source code of the implementation. We don't have access to the source code, so we simply can't test that. There are some things that we just don't want to test. For example, the specification also says that your implementation should resist DDoS attacks. So obviously, we're not going to DDoS the authorization server to test whether we can test protection against it. So we don't do that. But in general, most of the requirements that are applicable to authorization servers are implemented in our tool. So how does it work? So as already asked, so OAuch is basically set up like a client. It's just like a normal OAuth client, but it just does stupid things, and it just pokes and sees what happens basically. And it's basically just a malicious client that tries to do different things and logs what happens, right? And at the end of this process, you get a full list of things that are according to the specification, the OAuth specification, and things that are not according to the specifications, and that might lead to a vulnerability. So it acts like a normal client. It also needs access to some kind of API. Why is that? Because at some points, we need to be able to know whether an access token is valid. Right? And so how do you know how an access token is valid? Well, there are two choices. You can use an OAuth introspection protocol, which is basically like a protocol where you can ask questions about an access token. So you could ask the authorization server, is this access token valid? The problem is that almost no one implements this protocol, right? So we could use it, but yeah, then we would miss out of all these implementations that don't support this protocol. So OAuch actually chooses like the easy path, where they just say like, okay, let's take a very simple API call. For example, just call to get the user information, something very simple. And we assume that if we call this API with a valid access token, it will give some kind of response, HTTP 200 or 200 and something response. If the access token is invalid, obviously the API call shouldn't work. And then we would get a 400 or 500 HTTP answer. And so this is basically how OAuch tests whether an access token is valid or not. And this is of interest for some test cases. Okay, so let's take a look. Let's see what it actually looks like. So just as a reminder, so this is schematically what it looks like. So we have this authorization server. This is the thing we want to test, right? We have this OAuch tool. It acts like a client. And then we have this API server. We don't really care about it, or we don't test the security of this API server, but we just need it to test whether the access tokens are valid or not valid. Okay, so let's quickly take a look. So here you see the tool, so you can just open OAuch simply by going to OAuch.io, your favorite browser. And as you can see, you can just use like a social login. But for this demonstration, I'm simply going to create an anonymous session. And so right now, I'm logging in. Okay, this is an anonymous session. I don't have to give like a username or password. I'm logged in. I'm on the main dashboard. And yeah, it's a new account, so there's not much to see here. So what I could do is I could click on this Add New Site button, and then you would just have to like enter your OAuth client credentials that you generated through the normal OAuth enrollment procedure. But for this demonstration, I'm going to click on this Add a Demo Site link, right? And so what this does is it adds a new site, and it automatically fills in the settings of the Duende software identity server demo site, right? So identity server is like popular OAuth implementation. We have this demo site available. Anyone can use it. And just as an easy way to get started, you can just click this Add a Demo Site link. Okay, so I click the link. We suddenly have this demo site here. And as you can see, all the settings are there. So this is just, if you've ever set up like an OAuth client, this is all very familiar to you, the client ID, client secret, scope. This is for the API. So these are just normal settings, right? So this is nothing special. This is actually the same for any OAuth client. So the site hasn't been tested, so let's start a new test run. And so when the testing process starts, so you will see that a second window pops up, right? So the original window on the left here, this is the window that drives the testing process. So it shows the progress. It has some buttons that you can use to during the testing process to steer it. And the pop-up window here, this is the window that actually handles the OAuth callbacks, right? So whenever you need to log in, for example, you do it on this right-hand side window. And this is exactly what happens. So there's this test case code flow supported. So this is one of the ways you can use OAuth. So it's currently testing whether this flow works. How does it do that? Well, it sends the user to the login page of the demo website. And then hopefully, when you log in, it will actually return to OAuch and report that this login worked. So let's just do that. Let's log in as Bob. And as you can see, the testing process now really started. So you can see here all the tests that are run by OAuch. You can see that it has seen that the authorization code flow indeed works, right? And so now it's just running tests. Well, not necessarily all of the 113. It only runs the tests that are applicable to this particular authorization server. So what you might sometimes see is that there's an error on the right-hand side, right? And so this is actually normal because OAuch is testing the authorization server, and it's doing stuff that actually aren't allowed by the OAuth specification, right? And so sometimes the authorization server notices this, and it says like, hey, you can't do this. This is illegal, and it just stops. And so this is kind of a problem because then the testing process stops, and OAuch can't continue anymore because it doesn't know whether the process has failed, the test has failed, or whether you just are clicking around and logging in. So what you can do then is to click this stall test button here, right? So we'll probably see an error in a few moments. So you just here, this is an error, and you click this yellow button, this stall test button, and this basically informs OAuch that the testing process has stalled and that it must continue with the next test. But keep in mind, this is actually by design. So this is actually typically a good sign that the authorization server has noticed something is wrong. So the fact that you click on this stall test button isn't necessarily bad. Okay, so the testing process has already finished. So let's take a look. So we can see here, on the results on the previous tab, we saw some summary of the results. We can also see all the failed tests. So for example, this implementation does not exactly match the full redirect URI. So this is the example I gave earlier. So in this case, this is obviously normal because it's a demo website, so it can redirect to anywhere. But if you would do that in a real implementation, you would actually have something called an open redirector vulnerability, and that's something you really want to avoid, right? So it gives you an overview of all the things that all the tests that have failed. And as you can also see, it also gives you extra information. For example, it tells you the requirement level of the specific test. So it tells you these tests are probably more important than these failed tests. Okay. If you want to see why a particular test failed, you can click on this full log tab at the top. You just choose a test. Okay, this test has failed. You click on the plus button here, and it opens up and it shows you everything that's happened. So every HTTP post, HTTP request, redirect, token results, whatever, everything is there. And so you can just see what the test did and why it came to a specific conclusion. So this is what the tool looks like. Pretty easy to use, I think. I mean, if you are used to setting up OAuth clients, it's not much harder than that. But what does this really mean? I mean, so at the end of this test result, we get all kinds of numbers, like how many failures and which test cases have failed. But does that really mean that there's a vulnerability? Because it doesn't necessarily have to be that way. So, for example, there are multiple countermeasures that actually mitigate the same threats. So the fact that you're missing a countermeasure doesn't necessarily mean that you have a vulnerability. It can be that some other countermeasure actually mitigates the same threat, and so there's no problem, right? So to solve that, we actually took a look at the OAuth threat model, and we integrated that into the tool. So the threat model, that's a separate RFC. Somewhere a few months after the publication of the original OAuth specification, was it published also by the same guys who created OAuth? And it's basically like a long list of things that can go wrong if you're implementing OAuth. Okay, and so yeah, what do these threats look like? Well, they look like this. So you typically have a name, a number, a name, a description of the threat. So this is what can go wrong, and then. And this is the most important thing for us, a list of countermeasures that can actually be used to mitigate this specific threat. Okay, so this is obviously like the shortest example I could find in the threat model. So typically they are much longer. So the description is typically more elaborate. So they typically also includes like an attacker scenario that lists all the steps that the attacker has to go through. The countermeasures, sometimes it's one countermeasure, but it can be up to 7 countermeasures. So it kind of differs. But what's important is the fact that this list of countermeasures is always there. And this is something we can actually use because of the test cases, we actually know which countermeasures are implemented in your authorization server. And we can actually, from that, know which threats are mitigated and which are not mitigated. So we integrated this threat model. We actually look for 42 server-side authorization server-side threats. So these are threats from the threat model, but this threat model has been written in 2013, so it's kind of out of date. But we also included the threats from the best current practices. And so the best current practices, that's a document that's kept up to date with the latest information about OAuth security. So we look for these 42 server-side threats. We know for each of these threats which countermeasures can protect against it. So this is just information that's in the threat model. And we know which countermeasures are actually implemented by your authorization server, because this is what we test with the test cases in OAuch. Okay, and then we can compute what your results are. And so each threat is assigned one of 3 categories. So either a threat is fully mitigated. So this means the threat model says, like, okay, these are the potential countermeasures for this threat, and you've implemented all of them. So that's fully mitigated. It can be unmitigated. So this means the threat model lists a number of countermeasures, and you've implemented none of those. Or it can be partially mitigated. So this means you have at least one countermeasure that mitigates the threat, but not all of the suggested countermeasures. And so the end result is that OAuch can give you clear advice, can tell you like, okay, for this threat, you probably should mitigate this because you have no countermeasures in place against that. And these are the countermeasures that you can actually implement to mitigate this specific threat. So if we go back to our demonstration, so we scroll up again, and we go to this threats tab here. And so this is the list of threats. You see some threats are just not relevant because not every threat is relevant to every authorization server. Some threats are mitigated. Some threats are not mitigated. So these are threats that basically have not a single countermeasure in place. If we scroll a bit further down the list, we see this partially mitigated threat here. And again, we can click on this plus button. It pops open. And it shows you like, okay, these are all the potential countermeasures that you could implement according to the threat model. And you have implemented this one, but you haven't implemented these two, right? And so if you want to implement one of these, you just click on more info, and it tells you exactly like, okay, in this RFC, this section, that's where you need to look for the description of this countermeasure. Okay. Okay. So let's go to the results. So we basically use this tool on a large set of websites to see how well they were doing. And so what we did is we tested 100 publicly available OAuth implementations, OAuth authorization servers, 80 of which were just using like the plain OAuth as we all know it. So they had an API and they want to protect and authorize their API by using OAuth. 20 of these websites were also OpenID Connect providers. So OpenID Connect is an authentication protocol. So OAuth is only for authorization. OpenID Connect is authentication. It's built on top of OAuth, so it's highly compatible. And so we tested them as well. From the 100 websites, 75 of them were in the top 10,000. Actually, many of them were in the top 100. So it's not that we just tested all these sites that no one has ever heard of. So this list of 100 websites also includes like the big names like Microsoft, like Facebook, like Google's in there, LinkedIn, all these big names are in there and are in the results. And so what we did, so we tested these 100 websites, and then we just drew statistics all over our results to see how the actual state of practice within the general OAuth implementation ecosystem is. And it turns out that results weren't that good. So if you look at failure rate, which is just like the percentage of how many of these tests fail, then we get like a failure rate of 33%. So this means that on average, a third of all the relevant countermeasures for an authorization server are not implemented, right? So these are like the musts and the shoulds and the mays in the standards. A third of these are just ignored, not implemented. So if we split this down, split this up into the separate categories, we get more interesting results. So unsurprisingly, there's like 81% of the optional security requirements that they are not implemented, but that's kind of logical because they are optional. But 1 in 5 of the mandatory countermeasures is also not implemented on average, right? More than half of the recommended countermeasures is also not implemented, right? So that's actually a lot, and that's quite surprising. But again, like these are the failure rates of the individual test cases, so it doesn't really tell us much. So then let's take a look at the threats, and then we get this. So these are the partially mitigated threats, and so we can see that most of these providers have between 4 and 10 partially mitigated threats. So remember, a partially mitigated threat is a threat for which at least one countermeasure is active, but not all of the recommended countermeasures, right? So is this bad? I don't know, because they all have some countermeasures. So it's difficult to say whether they are vulnerable, but it's clear that in terms of security, that some improvements could be made. However, if we look at the unmitigated threats, and these are the threats for which not a single countermeasure is present, then we get this. And we see that most sites actually have like 3 or more unmitigated threats, completely unmitigated, right? And this is obviously bad news, right? Because this means that they are, in principle, ready to be exploited, right? And so actually, we only have 3 websites out of the 100 we tested that managed to get not a single unmitigated threat. So that have at least some form of protection against all the threats in the OAuth framework. So can this be right? So, well, obviously we doubted this because, I mean, this looks really bad. So what we did is we actually tested this. So we chose 4 attack vectors, and we used OAuch basically as an offensive tool. So we used OAuch to list all the potentially vulnerable websites for these 4 common vulnerabilities. And it turns out that results were actually highly accurate. So we had like 1.45% false positives, 1.48% false negatives. So that's actually low. So this means that the results of OAuch were actually highly accurate, right? So that's bad news. Can it really be that bad? Because so I mentioned that these are sites that, you know, in the top 100. So these are like Facebook and Google. I mean, these are the big guys, right? So can they have like multiple open threats that have no countermeasures? Can they really be this vulnerable? Is it really this bad? And the answer is probably yes and no. So yes, it's certainly true that they are missing a lot of potential countermeasures that they could implement. Almost no sites have optimal security in the sense that they have implemented all the countermeasures that are advised by the OAuth standards. So this is definitely bad news, and there's certainly room for improvement. But we must also put this in perspective, because if we look at the threat model, in particular the attacker model in the threat model, it actually assumes that the attacker has like unlimited resources, advanced capabilities. So it can sniff networks. It can control multiple parties in the OAuth authorization protocol, and so basically it's a threat model that protects against nation-state attackers, but like the real attackers simply don't have that capability. Right? So it doesn't mean that if OAuch tells you that that you haven't mitigated a particular threat, that doesn't mean that it's easy to exploit, right? It's exploitable under certain circumstances, but it might be difficult. Okay. And also, so OAuch basically, so OAuch assumes that there are no client mitigations, right? So we only look at mitigations on the server side, on the authorization server side. And so sometimes a client might actually mitigate a particular threat, even if the server doesn't mitigate that threat, right? So we actually assume like the worst case there. Is it a bad assumption? Not necessarily, because a lot of research has been done about this, and we also encountered it with our own tests, and we actually see that a lot of clients do not implement all the mitigations correctly. So in that sense, it's reasonable. But obviously, there potentially are secure clients that actually implement a lot of client mitigations, and for which the result you get from OAuch might be a little bit over the top bad, right? I mean, so maybe the client mitigations actually mitigate certain threats that are reported as unmitigated. Okay. So a second question that arises is, why are these implementations so bad? So why don't they actually just implement the standard, right? Because OAuth is a security protocol, so you would expect that people take great care in implementing it securely, right? And so we actually thought about this, and we have some potential reasons for this. And so some of these reasons were actually confirmed by the people we contacted when we were doing our responsible disclosure. So surprisingly, a lot of these providers claim that they actually know about the issue. So they know that these problems are there, but they want to maintain backward compatibility, right? Fair enough. It's important. You can't just break everything to get a little bit more security. The problem is that most of the things that we reported were countermeasures that were actually backward compatible. So backward compatibility is typically like a bad reason not to do it. Sometimes providers said like, well, yeah, these countermeasures should be implemented, but we simply can't implement it because it's not feasible in our circumstances. And I mean, there are good reasons. For example, if you're Google, you're handling like millions of requests per second, right? And you can't, for every request, go to the authorization server to check whether an access token has been revoked, for example, right? That's simply not feasible for them, so they don't do that. Fair enough, but OAuch tests countermeasures mainly in the authorization phase of the OAuth protocol. So they're actually not active when access tokens are used. So this argument typically isn't a good argument either. Sometimes they just plainly say like, yeah, well, we know that these problems are there, but we have other priorities, right? Again, understandable. I'm not sure if that's the best way to approach it. But so what they typically do is you have to prove that there's an actual vulnerability. So you have to actually write an exploit that exploits it. And only then will they fix that hole and nothing more, right? That's the way actually a lot of companies work. Again, probably not the best thing to do, but that's just how it is. And finally, they are basically just like shifting the blame. They're saying like, well, yeah, we could implement this countermeasure, but it can also be implemented on the client. So why should we do it, right? So let the client do it. Fair enough. The problem is, of course, that most clients won't do it. And so again, I don't think that's the best strategy. In many cases, of course, the provider didn't know that they had these problems. And so why were these problems there? Well, maybe the provider just followed the original OAuth standards, right? RFC 6749. They implemented it correctly. They did it perfectly. But this RFC is outdated. And so it's not compliant anymore with the latest best practices. And so, yeah, so their implementation actually has vulnerabilities because of that, because they are out of date. So one of the problems here is that the best practices document of OAuth. So this is the document where they just, whenever a new attack comes out, they describe it there and they describe all the potential countermeasures. That's published as a draft, right? It's not a standard because it continuously changes. But it's a draft. And we actually had one company that said like, well, we implemented the OAuth RFC, but we're not going to implement the OAuth security best practices because it's not an RFC yet, it's a draft. Yeah, okay, but that doesn't really make sense, right? I mean, so this is like the document with all the latest information about the security of OAuth, and you're not going to do that because it's a draft. Okay, well, it's a choice. Sometimes they make invalid assumptions. So things change in OAuth. For example, the Pixie countermeasure, that's a countermeasure against code injection attacks and also CSRF attacks. And so when it was introduced as a CSRF attack, it was actually only introduced for public clients. So these are clients without a password. But then they actually saw that this countermeasure was actually also a good countermeasure against code injection attacks. And so they made it mandatory, right? Not only for public clients, but also for confidential clients with passwords. And so we've seen implementations that do support this Pixie countermeasure only for public clients, not for confidential clients, even though it's now mandatory to implement in confidential clients. If you don't, you have a potential vulnerability. Sometimes they say like, well, we have this OAuth library. I mean, we don't care, so we assume that this library is correct. It will make us safe. And that's not necessarily the case. So first of all, you have to configure and use it correctly. Second, of course, it needs to be implemented correctly. But also, typically, some of the things are out of scope for the library, right? So like the actual web pages where the user has to log in, that's typically something that's not handled by an OAuth library. But these pages actually need countermeasures as well to be secure. So if you don't add these countermeasures there, then you might again have a vulnerability. Finally, it's so easy to implement. It's just like an HTTP redirect, an HTTP post. So why don't we do it ourselves? It's possible, but it's actually very difficult to do correctly. It's deceptively simple, and the devil is in the details. Okay, so what have we learned? So first of all, it's difficult to just give like an overall advice, like you should do this and then you're secure. It doesn't work that way. So one thing we saw is that for all the sites we tested, that they made different mistakes. And so we really need to give specific advice to each site. But there are some things that we actually can say. First of all, do not assume that if you're using an OAuth library, that it's safe. Test that it's safe using a tool like OAuch or something else, like the OpenID compliance tests, for example. Second, update your software. We've seen implementations that we know are over a decade old, because they are talking about specifications that were published, I think, 2011. So yeah, that's obviously a bad idea, right? Because OAuth evolves and new attacks pop up from time to time. Third, do not rely on the clients to do everything correctly, because they typically don't. Some clients do it, have like countermeasures and stuff, but many of the clients actually don't follow the specifications correctly and don't use countermeasures. So if you are implementing a new OAuth service, make sure that all these countermeasures are required, right? That you actually need clients to use them, or otherwise it simply won't work. Finally, so OAuth has been formally verified, so there's a mathematical proof that says that it's correct, and that's fine. But we obviously see a lot of implementation flaws, so it's still important to take a look at that and to make sure that even if you are using a very good protocol, that you actually are using it correctly. And even if you think you are doing things securely, we've seen from the experience we've had with the analysis of the entire ecosystem that a lot of sites can actually benefit from adding more countermeasures. Okay, so this was my presentation. So if you want to try it, you can just go to oauch.io. You can just add a site there and enter the settings and test it like that. Or you can use Docker to download the Docker file and run it locally. If you want to run it like in a local network or something. We're still actively developing it, so we were still working on it. So if you have like suggestions or problems, just let us know, and we'd be very interested in hearing about that. So with that, I'll leave it to you guys if you have questions.
Yeah, I have one. So the test itself, it requires a configuration, so an integration, let's say.
Yeah.
We have a very restricted set of let's say, consumers.
Mm-hmm.
Does it mean that the attack factor is smaller if you can't integrate?
So you mean if you can't create your own client?
Yes.
It will probably be smaller, but that doesn't mean it's safe, right?
No.
Yeah.
I'm just looking. Here, if someone can just first create his own client, he gets it by an automatic process.
So what we've seen is from the API, so that there's like the FAPI, the financial grade API specification, and they actively prohibit that clients can actually automatically register themselves. Yeah. So there is some kind of security in not having that feature. But on the other hand, it doesn't really like so OAuth can actually be used to attack authorization servers that use like clients that aren't yours, right? Mm-hmm. So if someone else manages to create a client, like one of your trusted clients, that you can still use OAuch to actually attack that. Okay. So you should still be careful, and yeah, sometimes might not be really compliant.
Okay, so it's also difficult to test any integrations that you do with third party.
Yeah, but it becomes a little bit more difficult. Yeah. Yeah.
You try this on very privacy sensitive websites like banks and or governments.
So there were some banks. So we actually hacked the Flemish government, so like the Belgian government, so like the CSAM thing. So that there was a problem there. But yeah, with it's me actually. So yes. We also had like a bank, and it's not a Belgian bank because it's actually very difficult to
you get the right access for banks because you need a client and they need certificates, and which is good. But we are actually looking at that. So if there's anyone here from a bank and they want to work with us, we'd be very interested. But also Google, Facebook, these are major sites that if you can hack them, that would be a major problem. And so they're in the list. So by the way, if you're interested in all the details, we have, if you go to OAuch.io, if you click on About, there's a link to a research paper with all the details, all the sites we tested, all the results, and so.
It's free?
Yeah, it's free, it's open source. There's a link, so if you go to OAuch.io, there's a link to GitHub, you can look at source code.
The tool test the authorization server. So I was expecting that your results would be about Okta or Keepo, etc. But you're talking about sites. Is that because as a user of these services, it's also about your configuration?
Yeah, so
it's kind of golden.
So just to be clear, so we are talking about authorization servers, right?
Yeah.
Google and so Okta and Auth and Auth0. So they have something that's like sitting in between typically. So we didn't test these here. We might test them in the future. But we are talking about the authorization servers of for example, Google or Facebook, like these things. So they typically have like an API and you need to access that API, but you have to authorize first at their authorization server. And that's what we're testing.